It's been discovered that there are a lot of weird and unusual things happening on Jupiter that we didn't know about. The first infrared images from the James Webb Space Telescope were studied, and new structures have been found within Jupiter's iconic Great Red Spot. A storm so massive and powerful its winds move at speeds of 270 to 425 miles per hour. 3.5 times faster than a powerful F4 tornado, and big enough to engulf our entire planet at once. Jupiter's Great Red Spot is a massive storm that's been swirling for centuries. But lately, it's been found that this enormous storm isn't as stable as it once seemed. It's wobbling, almost shaking, and its size has been fluctuating in ways that are pretty surprising. The Great Red Spot is shrinking. It used to stretch over 24,000 miles across, but now it's down to about 10,000 miles. But here's the twist. It's not just steadily getting smaller. The storm has been expanding and contracting, almost like it's breathing, and it's not exactly clear why. The wobbling motion is fascinating. It might have something to do with the wild jet streams and turbulence swirling around it. Jupiter's atmosphere is chaotic, and all that energy could be nudging and pulling the storm in different directions. On top of that, Jupiter generates a ton of internal heat, which could also be affecting how the storm behaves. Not too long ago, there was even a moment where pieces of the storm looked like they were breaking off and drifting away. That had some people wondering if the Great Red Spot was being torn apart. But here's the thing. This storm is powered by an insane amount of energy, so it's not going anywhere anytime soon. It might change shape or size, but it's likely to stick around for decades, maybe even centuries. The Great Red Spot's recent wobbling and size changes are just another reminder of how dynamic and unpredictable Jupiter is. And the new images we're starting to see are uncovering all kinds of mysteries about the gas giant. Approximately 10% of the way towards Jupiter's core, along its radius, the immense volume of hydrogen gas that forms the planet's atmosphere becomes compressed into a unique form known as liquid metal hydrogen. Liquid metallic hydrogen possesses properties similar to water, with low viscosity, excellent electrical conductivity, and efficient thermal conduction. Within Jupiter, this abundant substance transforms the planet into one huge generator. On Earth, elements exist as solids, liquids, or gases, depending on temperature and pressure. While hydrogen is typically a gas on our planet, it can be compressed and cooled artificially to become a liquid or solid. However, even in these states, hydrogen retains its non-metallic nature, poorly conducting heat and electricity. In contrast, metals excel at conducting heat and electricity due to their atom arrangement. Deep within the gas giant of our solar system, hydrogen undergoes extreme temperature and pressure, which allows for peculiar states including liquid metallic hydrogen. Hydrogen atoms under these conditions shed their electrons, resulting in a mix of free-floating hydrogen nuclei and electrons. This electron mobility resembles metal behavior. There's a theory that Jupiter's core might be filled with vast oceans of this substance, and based on previous estimations of the Jovian core's mass, it could be 12 to 45 times more massive than our planet. A 40,000-kilometer deep layer of liquid metallic hydrogen, combined with Jupiter's rapid rotation of about 10 hours, generates a colossal magnetic field that spans an astonishing distance of 725 million kilometers. This magnetic field stands as the largest in our solar system, and it contains mysteries of its own. Exploring regions more than 320 kilometers down into Jupiter's atmosphere, scientists have identified a newfound area known as the Great Blue Spot, not to be confused with Jupiter's Great Red Eye Storm. Researchers knew that the Jovian magnetic field was complex, but they had no idea just how weird it was. And it has something to do with the Great Blue Spot. The Jovian magnetic field is 20,000 times stronger than the Earth's magnetic field. But now, scientists have discovered that its strength is volatile. Unlike the Earth's dipolar magnetic field, the gas giant's magnetic field originates from a wide area in the northern hemisphere and re-enters near the South Pole. Researchers have also identified a concentrated region just south of the equator, the Great Blue Spot. Is like a second Jovian South Pole located near the equator. The colossal storm that's raged for centuries is probably caused by the presence of high concentrations of ammonia in the atmosphere. The intensity of the magnetic fields in the Great Blue Spot undergoes fluctuations of up to 1% per year, strengthening and weakening across different regions. By the end of the extended Juno mission in 2025, scientists will have ample evidence to evaluate their hypothesis. As research continues, we're going to encounter new mysteries about the gas giant. Since the Great Blue Spot and the Great Red Spot are located at the same latitude, it's possible the two phenomena are somehow connected. Gas giants are typically characterized by their high temperatures, especially in their upper atmospheres. In our solar system, there are two such giants, Saturn and Jupiter. However, Jupiter doesn't have a consistently high temperature throughout its entire structure. The solar system's largest planet is mostly known for its massive storm, twice the size of Earth, the Great Red Spot. But the gas giant has other spots too. The Great Cold Spot is nearly as large, and scientists have been observing this phenomenon for years now. At its largest, the spot is approximately 12,000 by 24,000 kilometers across. But unlike the famous red spot, this intriguing atmospheric feature stands out as a region of significantly colder temperatures compared to its surroundings, about 200 degrees cooler than the surrounding atmosphere. The Great Cold Spot is volatile, disappearing and reappearing from time to time. Scientists have discovered that this phenomenon's recurrence is triggered by the planet's auroras. Because of this correlation, the spot's age is about the same as the age of Jupiter's polar lights, which is in thousands of years. Jupiter's auroras, similar to Earth's, are produced by charged particles interacting with the planet's atmosphere near the poles. However, the gas giant's polar lights are more stable and intense, as they receive particles from both its moons and the Sun. New findings indicate that these auroras transfer energy to Jupiter's atmosphere, creating a temperature difference between the upper and lower regions. This temperature contrast leads to the formation of a swirling vortex, resulting in a cooler patch that is distinct from the aurora and its surroundings. Earth also experiences similar effects. However, the combination of factors like Jupiter's rotation that helps retain heat in specific areas and the varying nature of these events makes the occurrence of polar lights on our planet less consistent. Another discovery made about the gas giant was that, contrary to common belief, Jupiter doesn't actually orbit the Sun. The center of gravity between Jupiter and the Sun does not reside within the Sun itself, but instead exists at a specific point just above the Sun's surface. In space, where a smaller object seemingly orbits a larger one, both objects actually orbit around a combined center of gravity. Consider Earth and the Sun, for instance. In this case, the center of gravity is so close to the center of the larger object that its impact is hardly noticeable. The larger object appears motionless, while the smaller object traces a seemingly perfect circular path around it. The same happens when the International Space Station orbits the Earth. Both the Earth and the ISS orbit around their shared center of gravity, even though our planet seems to be completely stationary, while the ISS appears to orbit the Earth in perfect circles. This principle generally holds true for most planets in our solar system. Even Saturn has negligible influence on the Sun's position in space. However, as the difference in mass between the two objects decreases, everything changes. In the case of Jupiter, its immense size causes the center of mass, known as the barycenter, to exist 1.07 solar radii away from the Sun's center, approximately 7% of a solar radius above the Sun's surface. This means that both the Sun and Jupiter orbit around this particular point in space. Our ancestors knew the monstrous size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system, and 317.8 times the mass of the Earth. Jupiter's volume is 1,300 times larger than our planet's. But today, we've advanced technologies that help us learn more about the gas giant than just size and mass. and astronomers pay a lot of attention to the study of Jupiter as our planet's future depends on it. The latest data we have shows that, right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the solar system by astronomers because of its immense gravity well and where it orbits in the inner solar system. The gas giant has taken some huge impacts from asteroids that could have hit Earth in the past, like Shoemaker-Levy 9, which slammed into Jupiter as it broke into pieces in 1994. But the planet's gravity isn't always protecting us. Along with Venus, it affects the Earth's climate. Every 405,000 years, gravitational fluctuations between Earth, Venus, and Jupiter bring us abnormally cold winters and hot summers. Droughts become severe and rains cause floods. Researchers say we're now somewhere in the middle of this cycle, and if something goes wrong on Jupiter, it could affect Earth in a big way. So what is the weird thing going on with Jupiter? For once, its most famous storm seems to be shrinking, and we have no idea how that will affect the planet. The Great Red Spot is a huge anticyclonic storm on Jupiter. The largest storms on Earth are more than 1,600 kilometers across, with winds reaching up to 320 kilometers per hour. But these hurricanes pale in comparison with the Great Red Spot anticyclone, which is about 16,000 kilometers in diameter. The gigantic storm is circling Jupiter at 650 kilometers per hour. Astronomers discovered the Great Red Spot in the 17th century, and scientists still study this phenomenon. The distinctive color of Jupiter's Great Red Spot has been a mystery for a long time. Some scientists believe the storm is colored by complex organic compounds. The whirlwind lifts them from the inside of the planet into the upper layers of the atmosphere. Others think the rusty color comes from sunlight splitting up different chemicals in the anticyclone's upper atmosphere. If so, the storm isn't actually very red at all, and what we might see is just a sort of sunburn at the top of it. Another interesting question is why the anticyclone lasts so long. Scientists have suggested it's because of Jupiter's composition, which is mostly hydrogen and helium. The gas giant has no solid surface to frictionally weaken the storm. On Earth, friction reduces the wind speed near the surface. This slows down storms. But other planets in our solar system aren't like the Earth either. Saturn, for example, isn't rocky, and storms there don't last this long. The biggest storm on Saturn, the Great White Spot, covers several thousand kilometers. You can see it through a telescope as a white oval. This spot appears every 30 years and then vanishes without any trace. The Big Dark Spot on Neptune, which was discovered in 1989, was also proved to be short-lived. The wind around the storm reached supersonic speeds of up to 2,400 kilometers per hour. The large dark spot was constantly changing its shape and size. With that much activity, the storm was clearly not going to subside, and yet, in 1994, it disappeared. But let's get back to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019. It took images of the storm to help determine its nature. Using Juno's data, scientists compiled a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much deeper than previously thought. On Earth, a storm of this size would rise above the International Space Station. Researchers say that, taken from above, the cyclone looks like a huge pancake, but a really thick one, going 500 kilometers deep into the clouds of Jupiter. This is 50 to 100 times deeper than the Earth's oceans. The storm is powered by atmospheric jets that go far deeper, about 3,000 kilometers. Scientists are still trying to unravel the mechanism behind how these jets move. So far, there's only one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the jets. This is very different from the way things happen on Earth. On our planet, atmospheric phenomena are largely driven by water, clouds, condensation, and sunlight. This is what we'd probably see inside the Great Red Spot if we could get there. The gravity there would be intense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and stretched. Thanks to this effect, scientists picked up tiny tremors, 0.01 millimeters per second, and were able to calculate the gravity inside the storm. It turned out to be so strong, as if a mysterious planet was hiding at the bottom of the anticyclone. But of course, scientists didn't find any planet there, only a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its form from oval to round and shrunk considerably. Previously, 3 Earths would fit inside the monstrous storm, but now only one. Look at these Hubble telescope images from 1995, 2009, and 2014. You can see how the Great Red Spot has shrunk in just 19 years. So why is the storm on Jupiter shrinking? And do we have anything to worry about if the storm disappears? According to researchers, something in the planet's atmosphere is killing the storm. An unknown force is tearing apart the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that looked like a wave peeling off its eastern side. The Juno spacecraft also took an image of red flakes flying away from the spot. Researchers confirmed that formations of various shapes actually detach from the Great Red Spot and scatter into space. These huge chunks, up to 100,000 kilometers in size, are about the size of Portugal or Iceland. Computer models show this is a very natural phenomenon for Jupiter's complex atmosphere. It may happen due to the convergence of the Great Red Spot and smaller storms. On Jupiter, anticyclones are attracted to other anticyclones, and opposites, such as cyclones and anticyclones, repel. The merging of anticyclones is a long process. In the beginning, a smaller storm becomes a small bulge closely adjacent to the larger hurricane. Then, the larger storm merges with the smaller one. But when anticyclones meet with cyclones, something different happens. A clockwise rotation of an anticyclone and a counterclockwise rotation of a cyclone first bring them to an abrupt halt. Then the motion resumes with an unimaginable force and scatters the storms in different directions. A small anticyclone wouldn't merge with the Great Red Spot, but shatter into pieces instead. And these pieces of different shapes would then separate from the storm. This is what astronomers believe they are observing. And the Great Red Spot is still shrinking. According to scientists' calculations, it could disappear in about 20 years. Jupiter is unlikely to be affected, but there may be some irreversible processes that the storm was preventing. Only time will tell what will happen when the storm completely disappears. Based on data from the Hubble telescope, the average wind speed around the red spot increased by 8% from 2009 to 2020. And this means the anticyclone isn't losing activity and may increase in size again. Or it could be replaced by another storm. In 2000, 3 small oval white vortexes on the planet merged together. And at the end of 2005, a new hurricane turned red. Astronomers called it the Small Red Spot. In 2006, the Small Red Spot came into contact with the Great Red Spot. Because this was a slight collision, it didn't have any significant effect on the two whirlwinds. But how will the two storms get along in the future? To sort things out, NASA's mission Juno was extended for 5 years in 2021. The spacecraft will monitor mysterious polar cyclones, the planet's magnetosphere, and its incredible red storms. Jupiter continues to be studied by the Hubble and Webb space telescopes, as well as many ground-based observatories. What else could scientists find on the gas giant? And what's in store for the famous Great Red Spot? Let us know what you think in the comments, and be sure to subscribe to the channel so you don't miss out on anything incredible happening in our universe. Thanks for watching.